Hello, and welcome to this short video on how to migrate your Oracle databases to Azure in the cloud. My name is Martin Wild and I work for Quest Software, and I'm going to talk to you about those steps today. So you want to move your Oracle database to Azure, but why? Well, it could be you want to scale out and you want to use Azure to run your Oracle databases for, say, reporting or some BI integration. You might want to migrate your existing databases to a new instance in Azure. That is obviously an obvious choice if you're wanting to not replace your hardware and want to make use of the cloud resources to scale out your databases in the cloud. You might want a copy of your existing databases in Azure for your testing teams, and this is another quite common situation where you need a proper copy of your production system for all the testing that you want them to do, and you want to be able to spin those databases up and test them at will. And you might also want a copy of your existing Oracle database in Azure for HA purposes or disaster recovery. And finally, you might want a copy of your existing database in Azure for scale out purposes. And what I mean in this situation is where you might want for load balancing, you might want to have some of your workload go to an Azure instance at busy periods, but also onto the on-prem instances at quieter periods. And these are lots of different common requirements that you might have. So let's have a look at how we go about migrating an Oracle database to Azure. There are some considerations that you might be thinking about if you're looking at a project such as this. Have you thought about downtime? If you're going to do particularly a migration, there's a considerations around how you're going to switch across your applications from on-prem instances to the Azure instances. How long is that going to take to be able to set that up? Now, this isn't always a problem for some customers. If you have a situation where you can take a couple of days off offline to do this job, then that's fine. But for a lot of situations, this isn't something that you have the ability to do. Now, what about testing? This is also quite a tricky area because, when you're moving from an on-prem situation into Azure, there's a lot of security, networking considerations to bear in mind that you'll want to do some rigorous testing of your interfaces, etc. And so having the time to be able to do that is important rather than just doing some quick checks before you switch across. Another consideration is failback. What if after a few hours of cutting across to your new instance, somebody detects a particular problem with one of your interfaces not being configured correctly, and you need to fail back? What are you going to do in that situation, particularly when you've updated the target database in Azure? It's not something that you can just say, well, let's go back to the original on-prem instance. So you need some insurance policy for that. And then what about performance? How are you going to specify what the configuration should be in Azure VMs to get the right performance comparable with what you had on-prem, but also thinking about the cost implications of that. So if we look at some of the typical tasks that you'd want to go through is you might, for example, want to do some pre-migration benchmarking. If you're going to move across to Azure, what you don't want is for people to think that actually there's some performance issues because they may be more anecdotal and not actually true. So you need to be able to prove that, but also if you're working out what sort of VM you're going to need to do some benchmarking for that. Also, if you're going to do that, worth doing some pre-migration performance monitoring to look at the workload characteristics. Do you need to be considering when your busy periods are? What sort of wait events do you have? You may need to look into that to see, are you just carrying across problems that you've already got, or how do you manage the requirements that you've got on the target? And the balancing the costs if, for example, you only have a busy really intensive performance issues at one time in the month, for example. Do you want to pay for that for the whole month if that's the only bottleneck that you have? So looking into those sorts of issues and getting an idea of who is accessing this database, what are they doing, what are the performance characteristics can be quite useful as an initial assessment, and particularly when looking at the benchmarking to be able to see what your benchmarking does and how that works with the performance. Another interesting topic here, depending on the customer, obviously, is around the assessment of sensitive data. There may be some regulatory issues about when you're moving to the cloud that weren't an issue on-prem, but become an issue in the cloud. And certainly around test databases would be a prime example there, where it may have been acceptable to have a production database on-prem for testing, but it may be that you need to remove some of the PII data from that database if you're going to have that in Azure. So other little considerations for you. And then you do the migration to the target instance. And then you might want to do some post-migration benchmarking just to see how has everything gone as planned? Are you getting the performance that you'd expect on that instance? And with that, as before, some post-migration performance monitoring to see what those characteristics are. And I would say that's probably important in terms of like if you're moving from 11, 12C to 18 or 19C, that you'd want to check whether new features or new adaptive plans or something like that are causing you issues on the new database. And finally, it's obviously important as an ongoing practice to balance cloud database performance with cost control. It's as with any sort of infrastructure like this, it's too easy just to keep adding more resources, and that's obviously going to push your costs up. Particularly if you're going to want to scale out with test databases and things like that, just to check that you've got a way of making sure that you're not overutilizing these databases for no reason. Okay, so when you moving the database across, another one consideration that Quest can help you with is obviously the management tools for that. So you might be familiar with Toad for Oracle to assist you with managing these two databases. And that's not the only area that Quest can help you with. If these are the sorts of considerations that you want, like reducing the downtime that we mentioned earlier, we can help with that. We can help with the testing, allowing more time for testing, provide you with a failback alternative, such as if something goes wrong, being able to go back to the on-prem database temporarily until you can fix that issue. We can help with that, as well as doing all that performance monitoring that I've mentioned before and after, and doing things like pre-migration benchmarking and sensitive data detection. So that's what I'd like to talk to you about today. So typical steps that you might take to move your database across would be to build your VM, build your database, set that up, and then you would normally then say stop your database, do an RMAN backup or whatever method you're going to use to get your database into the target, do some testing, and switch the application over to the new target instance. And what we're really trying to say here is what are the issues here, like the time and the risk involved. What if things don't go to plan and it takes longer than you had promised the business? Do you need the whole database? And that goes back to the issue around like test databases, or reporting. Do you actually need the whole database, or could you have a subset of the schema there, but in sync with your target, with your source database? And other considerations would be like if you're moving from Solaris operating system to Linux, that might be an issue in how you do that transfer of the data across. So things to think about. So the way that we could help in this area is like if you build your target VM in Azure and build your target database, and then we could add some additional steps in here, like benchmarking the existing database for a later comparison. Monitor the source database to profile it, do any health checks that you need on that target database. Obviously, the longer you can do that, the better, so that if you've got, say, quarter end production processes or month-end or weekly type processes, the more the better to get that profile. Go through that process of identifying where your sensitive data is and decide what you're going to do about it, whether you're going to use Oracle features like redaction or encryption or auditing just to see who has access to that data. Um, and then you can go through the process of installing SharePlex and you start the replication of the data changes. You run an RMAN backup on the source and transfer that to the target and restore that backup. And then you allow SharePlex to post those changes and sync the database to a particular point in time. And then you can start running some testing, and then you can monitor the database and for performance profile and get some more intelligence again, and then run that benchmark to do the comparison to see whether you're getting the right type of performance that you're expecting. And then you can initiate replication from Azure instance back to the on-prem. That's the insurance policy if you wanted to go back. And then you can switch the applications. We'll go through this in a bit more detail shortly. So let's have a look at those in more detail. So on a pre-migration benchmarking, what do we mean by that? Well, you've got some industry standard TPC benchmarks that you might want to run through just to get an idea of what you get from your existing hardware and database version, in terms of CPU, memory, and storage, etc. So you get a good benchmark of what that would look like. What you can also do is record some activity on that database, and that would allow you to replay that. So you've got TPC's standard industry benchmarks as well as typical user loads that you might have on your database. And if we take those and have a copy of that, then we can replay them. But we can obviously replay them as part of migration, but also replay them as part of an ongoing benchmarking of the target instance, that we're just checking that we're not degrading in any way. Okay, and doing these benchmarks will also give you an idea of what performance level you need on the Azure instance. If we do the performance monitoring, that will give us an overview of what sort of characteristics we have of the monitoring, in terms of wait events and any change tracking things that we want to pick up. We can sort of compare any changes that we want to make at this stage, and we can drill down to particular dimensions within the database to do some very detailed granular performance monitoring, either like at action module level, PL SQL block level, or SQL statement level. And that's what I meant earlier on about if we had start identifying things that are like bad execution plans, why migrate that same problem across if we can fix that at early doors, and then it's not going to cost you more on the target system. So we can get all that away, and we're going to use this later on when we want to do some comparisons. I mentioned about the PII data, so allowing you just to scan through a whole schema, looking at the tables and looking at the contents, so not just the column names, the naming conventions, but also the contents. We have some out-of-the-box type policies like telephone numbers and addresses and email addresses and things like that, but you can customize that. So if you have particular things that you store that is personal identifiable information, you can create your own rules and add that in to be scanned for, and then you'll see from there that gives you the ability to then address some of these issues by adding redaction policies if need be, or at least documenting what it is that you might want to do something about before you migrate that to the target. Okay. So the next bit that I wanted to go through is just a bit more detail about this migration process. The software we're talking about here is called SharePlex, and the architecture is really to look at a source database and grab the information from the redo logs about what's changing in that database. So this is can be used as part of a migration, but you mentioned, and I mentioned at the beginning about having BI reporting databases or test databases. It can be used as an ongoing synchronization method to sync to one or more instances, for that matter, together, so that whatever's happening on the source will be replicated out to the target. So if you update 1,000 rows, that will be captured from the redo logs. That will be sent through the export queue over the VPN or the internet to the target post queue, which could be like a cloud instance. But we just basically regenerate the SQL statements and apply those to those target databases to synchronize them. That's the process we go through. And data is moved from source to target as soon as it's seen in the redo logs. It's like an optimistic commit type process. So rather than waiting until it's committed, if it's rolled back, we'll roll it back on the target. But the stream is going through, and you can have multiple queues as well. So if you've got like a big transaction, it doesn't necessarily need to hold up some smaller transactions that are running concurrently. So that will help eliminate any latency that might be there and keep the stream of data going. So as updates are applied, they're applied on the target ready for commit. Okay, so that's how we keep the databases synchronized. If that is something that you wanted to do for, as I said, for reporting, you can do it that way. It's very straightforward, the process of using SharePlex. You install it on the source and the target server. It's a very sort of low overhead. You can get around not installing it locally, but we're not installing things on the database. It's more of an operating system process that's looking at the redo logs and then connecting it to the database. So it can be done remotely if necessary. But you install it on source and target, and you build a list of tables that you want to replicate. And that can be like at a schema level, or you can list the tables. You can also do like individual columns on a table or particular rows in a table if need be. And once you have that configuration set up, you would perform an online backup and recover on the target to a particular SCN, and then you can tell SharePlex to apply all changes that have happened to the source database to that particular SCN, and then everything will be applied and you will get synchronization there. So if you're thinking about like using like a physical copy, you set that replication up, uh, you stop the post queue before it doesn't actually apply anything. There's nothing in the target database at this stage, but all changes to that point in time are all being recorded. There are various different methods of backing up and restore, such as RMAN and data pump and exports. But as long as you can recover to a log number and SCN, uh, this is the sort of key aspect here, is that how long will that take? And obviously, the bigger the database, the longer it will take to do the backup, to transfer the data and restore the data. And it doesn't matter how long that's going to take, because we are keeping a copy of all the changes that are taking place up to then. The main limitation really is looking at how many updates or inserts are being applied, any changes to the redo logs. The bigger that is, then the more data needed on the target system to store that. Once the restore is complete, you do a reconcile, and then from that point in time, we'll start synchronizing those two databases together. And I say databases, but this could be a subset of tables, as I mentioned earlier. It doesn't have to be the whole instance. Um, and this is the other bit that I mentioned about your insurance policies. Once that's in sync, you can then switch that round so that replication of anything new being applied to the new production system will be replicated back to the target. Not completely, we'll leave that in the post queue so that you have the option then to move your new users to the new system. Okay, and then we start replicating back. So that switchover can be quite a small point in time. Okay, but we would have the ability to go back if needed be, as a failback opportunity. So if we fail back, we would then switch the replication back the other way. But the idea is we're keeping both databases synchronized. Okay. Um, how do we actually specify what we're wanting to replicate? I just thought I'd throw this up. It's a very simple configuration file. You tell it what type of tables that you want to replicate, either by explicit naming or a wildcard, or you can sort of expand the whole schema. And then what you want them to be called on the target. They don't necessarily need to be like for like naming. You might want them to have different names on the target. And the targets can be multiple targets. You could have multiple test databases, for example, and then you have the routing map. And this is seen as like a key strength because you don't have to do a lot of configuration on both systems. There's nothing to do on the target. You just do this in the source, you activate it, and then that will start capturing all the changes for that particular configuration. So if you are moving to your database to Azure, then we're helping you with these risk-free migrations, moving the data anywhere. So if you're wanting this data for like reporting, that might be really useful for BI type purposes. Offloading some of your reporting, a sort of high availability type option, as well as if you need to relieve, if you've got performance problems on your on-prem database and you're looking to relieve that, then this is a good way of doing that as well by utilizing Azure resources for doing that, and any other sorts of projects that you might have. So those are the sorts of 6 sort of use cases that you might be interested in. So once we've moved across, we could do some post-migration benchmarking. As I mentioned earlier, obviously the TPCs aren't really relevant anymore because we've got our database up and running. So we might want to rerun those actual load cases that we recorded and replay those, and then we can do those comparisons. Are we getting the same level of performance for user load on the new target system? And then we've also got our performance monitoring where we can drill down and see, how are things performing? What do the queries look like? Are we getting the same sort of workload profile, as well as doing those comparisons and looking to see how each of the instances are performing with that similar workload that we had, and we can, see where there's any performance problems. And then the final point that I mentioned earlier on around needing to balance performance with cost is this ongoing idea that we can monitor this instance in the cloud and sort of see where we start getting performance issues, and work out what the best approach is. So if we're seeing complaints about particular performance, we can identify where they are, by program, by user, by PL SQL block, module action, for example, and then decide, is it an IO related issue, CPU related issue, memory related issue, and address those. Okay, so that gives you a sort of brief overview of our methodology and how Quest can help, and thank you for listening. Okay, so in summary, what I've been talking to you about today is that you have obviously Toad for Oracle to help you manage your on-prem and your Azure-based Oracle instances. We talked about using Benchmark Factory for load testing and benchmarking on-prem and Azure databases, as well as Foglight for databases for monitoring your Oracle instances on-prem and in the cloud and doing those comparisons. And finally, the SharePlex product for doing the replication and the synchronization between the two.